Episode 4, PDCA, a cycle. General Motors, the largest manufacturing company on Earth. That year, they recalled 1.5 million vehicles for a defect their own engineers had identified 2 years earlier. 2 years. They had the data, they had the diagnosis, they knew exactly what was wrong and exactly how to fix it. And nothing happened, because they planned, they did, they checked, and then they did not act. One letter, missing. That missing letter cost 1.5 million vehicles, 1.5 million customers, and decades of lost trust. When Deming gave the same framework to Japan, they used all 4, every single time. Today, you'll understand why these 4 letters are not a management idea. They are engineering law. Let's go back to 1939. Walter Shewhart, Bell Labs. A simple question. How do you improve a process? Systematically. Not by luck, not by accident, by design. He created a cycle. Then came Deming. He refined it into 4 phases. Plan, do, check, act. He took it to American industry. They said, "We're already winning." So he went to Japan. Japan listened, not politely. They implemented it, everywhere. And between 1950 and 1980, Japan transformed, from cheap products to the most reliable in the world. Toyota, Sony, Honda, Panasonic, all built on 4 letters that America ignored. The engine. 4 letters, 4 phases, 4 gears in one engine. Plan, do, check, act. This is not a checklist. It's a cycle. A self-correcting system. A system that prevents you from making the same mistake twice. When one gear stops, the others keep spinning, but without purpose. That's how organizations stay busy and never improve. Let's start the engine. Plan. Plan means define your objective, identify your risks, allocate your resources before you start anything. Ask 3 questions. What are we trying to achieve? What could go wrong? What do we actually need? When planning works, NASA planned Mars missions for 4 years before building anything. They identified 8,000 failure modes. Result? A rover designed for 90 days, ran for 15 years. When planning fails, a factory installed new equipment. They planned everything, except heat. Day 1, 42 degrees Celsius inside the facility. Production stopped. 6-week delay, 4 times the cost. The risk was in the data. Nobody asked the question. Do does not mean just execute. It means execute in a controlled way. Small scale first, so you can learn. Toyota does pilot builds, 50 to 100 units, every issue recorded, every deviation logged. Result? Industry-leading quality at launch. Now failure. A pharma company launched on all 12 lines. Day 1, seal failure. Root cause, humidity interaction. All production quarantined. 1 pilot line could have prevented everything. Check. This is the most skipped phase, and the most important. Checking is not collecting data. It is making data impossible to ignore. 3 steps. Measure, compare, analyze. Most organizations stop at measurement. That is not checking. That is record keeping. Motorola didn't just measure defects. They analyzed variation. They found 80% of defects came from specific causes. They eliminated them. From 6,210 defects to 3.4 per million. That is, check done right. Measurement without analysis is expensive record keeping. Analysis without action is expensive theater. Check requires organizational courage. Act is where improvement becomes permanent. 2 outcomes. Standardize what works, eliminate what doesn't. Toyota rule. Standardize within 48 hours. Not later, not eventually. Immediately. Failure example. A defect was fixed, but not documented. 3 months later, the same defect returned. Why? The knowledge was in a person, not in the system. Act is not closing the issue. Act is making the improvement impossible to reverse. Full cycle. Let's apply it. EV charger development. Plan. Identify thermal risk at 48 degrees Celsius. Do. Run simulation first. Check. Measure temperature. 14 degrees Celsius below limit. Analyze cause. Ventilation equals 70% impact. Act. Standardize the design. Document it. Result. Certification in second prototype. No third prototype required. Solve it once. Never solve it again. 5 mistakes, 5 ways organizations break. PDCA. 1. Planning without risk. 2. Full-scale implementation. 3. Measuring without analysis. 4. Fixing without standardizing. 5. Stopping after 1 cycle. PDCA is not problem-solving. It is continuous improvement. The first cycle is not success. The 10th cycle is. PDCA is not a quality tool. It is a way of thinking. Every real problem follows this pattern. You think you understand it. You build something. You discover you were wrong. You improve. You learn. Without check and act, you repeat mistakes. With all 4, you improve every cycle. That is engineering compound interest. 4 episodes. You now understand why ISO exists, what changed, the principles, and PDCA. Next, Clause 4. Context. The foundation most companies get wrong. This week, run 1 PDCA cycle. 1 problem. All 4 steps. Document it. See what changes. 4 letters. 2 are not optional. Now, let's give you an example of real case study from one of my project based on PDCA cycle. Plan. Objective. Design an IP66 rated AC charging unit for domestic outdoor installation. It must meet IEC requirements. It must achieve IP66 rating without increasing process or tool cost, and it must stay within cost targets. Risk identification. Gun holder socket integration with the body, while maintaining IP66 sealing, was identified as the highest risk parameter. Planning decision. Complete 3D design analysis to validate IP66 feasibility before finalizing any components. DU. First controlled prototype. 3D design only. No physical build. The lowest risk, lowest cost experiment. Failure discovery. The 3D design revealed an IP failure at the mating area of the gun socket. The solution? A new groove geometry. To create compression for the O-ring on the mating surface of the gun socket front fascia. Groove width and height were finalized, based on silicone O-ring hardness, before a single component was ordered. Check. The first physical prototype was built. Tested for IP65. IP65. Pass. Now tested for IP66. IP66. Failed. Analysis performed again. A flat silicone gasket was introduced, covering the leakage path. Additionally, machine screw bosses were added to increase compression. Flat silicone gasket and O-ring contributed 70%. Machine screw provision contributed 30%. ACT. The gun socket assembly design was standardized, documented, version controlled, communicated to manufacturing. Test results became acceptance criteria for all future builds. Result: IP66 certification achieved on the second prototype. No third prototype required. Patent filed for first of its kind, Type 2. ACEV charger with gun socket enabled in the charger body. Meeting IP66 rating. Subscribe. Hit the bell. Join the Omni Forge community. In the next episode, we explore context of the organization, the clause that breaks companies.